Welcome to the fifth technical lecture for the political economy of the environment. Last time we talked about how incentive-based regulations, such as taxes or permit systems, can be used to achieve efficient levels of pollution reduction in a cost-effective manner. Incentive-based regulations effectively put a price on environmental degradation. They lead firms and consumers to protect the environment when the cost is less than the tax or the permit price. Today we will discuss why incentive-based regulations may be especially important for addressing climate change. Consumers can reduce their carbon emissions by driving less, retrofitting their homes, taking fewer flights, or wearing sweaters in the winter. Firms can reduce emissions by increasing energy efficiency or converting to renewable energy sources. It isn't obvious which actions will be the most important and least costly method of reducing carbon emissions. A carbon tax or a carbon cap can give everyone incentives to reduce emissions in the least costly manner. Assume that Springfield is deciding how it is going to reduce carbon emissions. The city's demand for carbon emissions is given by the equation C equals 3,000 minus P, where C is equal to the number of tons of carbon emissions per day, and P is equal to the price of pumping a ton of carbon into the atmosphere. Note, this daily demand curve for a city of about 250,000 people is consistent with the U.S. demand curve underlying Boyce and Riddle's research. To graph the demand for carbon emissions, rearrange terms so that the price of a ton of carbon is a function of quantity, or P equals 3,000 minus C equals marginal benefit. We can graph this curve as a marginal benefit of carbon emissions, which could also be thought of as a marginal cost of emissions reduction. The marginal benefit curve has an intercept of 3,000 and a slope of -1. It looks like this. If it costs nothing to emit carbon, firms and consumers in Springfield will emit 3,000 tons of carbon a day, at which point the marginal benefit of emissions is 0. Suppose that, after careful study, policymakers in Springfield determined that the marginal social cost of carbon emissions is equal to $500 per ton, and they decide to place a $500 per ton tax on carbon. Note that this tax is considerably higher than most proposed carbon taxes, including the $200 ton tax you will consider in your homework. But let's say that the residents of Springfield are convinced that they should use a very low discount rate when considering the future benefits of emissions reductions. If Springfield places a $500 tax per ton of carbon, how much carbon will the city's consumers and firms emit? We can find out by calculating at what quantity the marginal benefit of emissions is equal to the carbon tax. We see that a $500 per ton tax will reduce emissions to 2,500 tons per day. How much revenue would the tax raise? Simply multiply the $500 tax times the 2,500 tons emitted each day to see that the tax would raise $1,250,000 or $1.25 million each day, as illustrated by this blue rectangle. Does this tax create or reduce society's total surplus? Given our assumption, the answer is that it increases society's total surplus. If the long-run environmental cost of a ton of carbon is indeed $500, the tax actually increases the total surplus by avoiding carbon emissions when the marginal benefit is less than the marginal cost. The carbon tax increases long-run total surplus by $125,000, as illustrated by this red triangle. Of course, most of the benefits of mitigating climate change will be enjoyed by our grandchildren and our great-grandchildren. If we were to assume that the current generation receives none of the benefits of reduced emissions, then a tax would reduce the short-run total surplus by $125,000, as illustrated by this second blue triangle. Once a tax is implemented, Springfield residents will choose to abstain from some carbon-intensive activities whose long-run costs exceed their short-run benefits. Residents may choose to keep their homes slightly cooler in the winter, or use more renewable energy, once they are forced to pay the true social cost of carbon emissions. However, the main insight from this simple model is that the short-run costs of a carbon tax are dwarfed in magnitude by the tax receipts which come to $1.25 million every day. A carbon tax would significantly raise prices on energy and other carbon-intensive goods, and it could lead to the public's rejection of the policy. For this reason, some economists have proposed a cap and dividend policy, which would rebate the revenues from a permit system on an equal per capita basis. Let's analyze how a cap and dividend policy would work for Springfield. In a cap and dividend scheme, the city would auction off carbon permits, assuming that the long-run marginal cost of emissions is $500 per ton. How many permits should they auction off? Well, again, they should allow emissions until the marginal benefit of a ton of carbon no longer exceeds the marginal cost, which means that they should auction off 2,500 permits. In a competitive bid, permits would auction for $500 each, and the auction would raise $1.25 million, just like the tax. In a tax and dividend scheme, these revenues would be rebated to the public on an equal per capita basis. Since there are 250,000 people in Springfield, that comes to $5 per person per day, or $1,825 per person per year. The key to the tax and dividend is that most Springfield residents would pay less in the form of higher prices than they'd receive in the form of their dividend. Assume that Springfield is representative of the U.S. as a whole, so that the poorest 70% of residents are responsible for 40% of the emissions, and that the richest 30% of residents are responsible for 60% of the emissions. On average, then, poorer residents would pay $2.86 in higher prices each day, and richer residents would pay $10 in higher prices every day. Since everyone would receive $5 back as part of their carbon dividend, most people would be better off with a cap and dividend policy. The policy may make it possible to significantly increase the price of carbon-intensive goods without triggering a public backlash. On your own, consider the following. Assume that without a tax, Springfield emits 3,000 tons of carbon per day, but that its demand curve is actually given by the equation C equals 3,000 minus 2p. The government still caps carbon emissions at 2,500 tons per day. It auctions off the permits and rebates the proceeds on an equal per capita basis to its 250,000 residents. Now, how much money would the cap and dividend system raise? What would the dividend be for each resident for Springfield? Do you think that there would be public support for the policy? Why or why not? Thanks for listening to your 5th technical lecture on the political economy of the environment.